Today I talk about something interesting, which is called protocols or interfaces, depending on which system you are developing for. So protocols are used in iOS, in Swift, and interfaces are used in Kotlin Android. So what are these functions? This function is created because nowadays applications are more difficult than the early days applications from the 70s or 80s. So in those applications, the applications were running on one thread or one thread. This thread was just running as it was. So basically the program code was running from the beginning to the end. You had some subroutines or procedures, and these could be called from the thread. But in this case, this thread was going through these procedures or functions, and then it went back to the calling position or the calling place from where it was originally called, or it could go to a different location depending on the program structure. But the nowadays applications are running on multiple threads. So we have the application main thread, and we have the so-called asynchronous threads, where the application is running parallel with these asynchronous threads. Where these are used, so for example, you can imagine that you have an application which is loading data from the internet, and for that it's sending out some requests, and then it is receiving the answer from the web server, and this answer should be handled by the application. But in the meantime, the application should not be stopped or should be responsive. So it should not show to the user that it's stopped or it's hanging, because this is not really a good let's say it's not a kind of good behavior from an application, that it seems like it's hanging and it's not working. So while we are waiting for the answer from the web server, the application should do something, or at least we should be able to cancel this request, or we should be able to do something with the application, maybe to change to another application and so on. So when we are using this kind of threads, the main thread and the asynchronous threads, then you should consider it like that the application is on the main threads, typically running UI updates, as I mentioned, that you can touch the surface of your phone, you can scroll or whatever you can do with the application, and at the same time you should have these asynchronous threads, where typically you are running something which is a long time executed code, or you are loading data, you are making calculations, and so on. So how it works, the application starts, of course, as usual, and then it try to request, or it will request an asynchronous execution of the code. In our case, let's say we are having a data request from the network or from the internet, and then this code should call the asynchronous execution code, and in the meantime it should continue to run. How we can do this? That basically when we are running the application forward, then we need to make sure that when we are finishing the asynchronous thread, then we are getting an information that part of the code was completed, the data received, or the calculation was done. And we should inform the original main thread or any part of the application that this code is executed and finished, and we have the result, and then we should display the result, or we should do something with it. So to get this this information back, we need to make sure that the asynchronous thread is having a delegate variable, which is then showing to the asynchronous thread that where it should go back. So in this way, you say that the delegate is called from the main thread, and from the main thread it should come back to a specific point inside the program. So here what I try to show you is that until this second black arrow is ending, the application should run, and then it should basically either wait for the results, or it should do something instead. So then the asynchronous thread is running, and when it is finished, then the protocol function is called, or the interface function is called, and actually this protocol function is also let's say implemented in the main thread, or in another thread, and then the program execution can be continued, or as I said, the results can be displayed. So this is basically how this thing is working. And now I would like to show you that how we can imagine this. So I created for this a very small sample application for both systems. So here you can see the Android system, and we also have here the iOS system set up in a similar way. So we have two text views, or edit text objects where we will write in something. So we are now emulating here a long time running code. So what is behind this application, that this text edit field here in the top is actually modified. So basically, when I'm pressing the button, then I'm calling this asynchronous thread, which is in this case will be this edit text object modified on a way that this will simulate that the long time running process is executed. So just to show you, and when it is finished, actually, then at the finish of the execution, the protocol or the interface function is called, and it's giving back the process to the main thread. So where we were calling, or from where we were calling the asynchronous thread, and then it will display a text in the second edit text field, which is showing that the protocol is called, and the asynchronous thread was giving back the execution to the main thread, and basically following up the results. So basically it's trying to simulate that how you might request data, for example, from an internet web server, and then when you get back the data, then you can basically display this information, or you can evaluate what you received, and you can do the job with it. So let's see how it works. So when I'm pressing the start button, then in the first edit text, it's saying that the background task starts, and when the timer is finishing the task, then the protocol was called, and then it goes to here. So similar thing in iOS. So here we press the button again, background task started, and then it's finished. So just quickly again, both cases, background task running and finished. Okay, so let's see how it works in the practice. Let's start with the iOS. case. So just quickly go through the elements. So we have a view controller defined here, and this is in the screen. And for the emulation purposes, I was using this field in the view controller, emulation start text. So here this outlet is linked to here, and we were or I was making a kind of subclassing of a UI text field. So basically I was making a UI text field subclass, and I created a very simple task here. So when the button is called on the main screen, then I'm calling this simulate background task execution, and then I'm writing into the text field or the itself a text which is showing the background task started, and then I'm having here a timer, and when this timer is completed, so the 5 seconds ended, then I'm calling the protocol function, which will call in that case the view controller's delegate function. So that is the logic behind. So here you can see that I have here the view controller with these two fields linked here into the outlets, and then I have a button here, and this button will call the emulation start text simulate background task execution function, which is defined in the background task emulator UI text field subclass. So just to explain that how you need to create protocols. So at first you need to have this asynchronous task which will basically define this protocol. In the iOS case or in the Swift case, the protocols can be defined as a separate item, so it's not really part of the class itself, which we use it. But when you define the protocol, you need to define some functions with it, within it, which will be called when you will work with this delegate function or delegate protocol. Sorry. So then you define a class, or you have a program, a view controller, or whatever can be using this kind of protocol solution. And then in the class, you need to tell to the class that how you want to call or where you want to call the background the protocol itself, the protocol function. But for that you need to define a variable which will contain the address of the delegate function itself. So where we will go back into the application code or where the application thread, let's say. So then you have your functions actually. So what you are defining your code itself, and within your code you should have somewhere a point where you are defining that okay, now I'm finishing the job, and then I want to go back to my main thread or the other asynchronous thread or whatever thread it's calling these objects, and then there we need to tell to the application that where to go back. So here we have to tell that we are going back to the task delegate, which is here this variable, and we will call the background task executed function, which is this one. So why we need to tell this? Because of course a delegate can have many functions. So you might have here a function which is, I don't know, background task status function, for example, and then you might give back or this function might this function might be called with a variable like I don't know, result, or no, status int. Okay, so let's say, you know, when you are defining more functions, then of course you can have a, I don't know, func report status, and then you just maybe do this, and then you say like percentage, okay, I don't know, int 50. So this will tell that 50%, and then you basically do something similar like this, and then you say background status, and then you say percentage. Okay, so like this you can create a function where you are, or you can have a protocol where you have many functions, and these functions can report to the application different things, and can go back to different location inside the application. So which are these locations in the other part of the code? So if we go back to the view controller where we were calling actually with the button, pressing the button on the surface. At first we were cleaning out the finished text to 0 or to nothing. Then we are defining the task delegate of the background task text field, so which we called emulation start text. And what you can recognize that we had here this task delegate. This should be a public variable for sure, because we want to tell that where the application should come back or should go back. And now we say here that we put this task delegate to self, and self will be basically this view controller. And from this, the asynchronous task, or the protocol function call will be known that where it has to go back. Then we are calling the function itself. But how the view controller knows that he has to take this function, or has to accept this protocol call, that we have to add behind the class definition. We have to tell to the application or this view controller that it is part of, or it will have a background task emulator delegate. So basically this protocol delegate. And as you can see, this protocol delegate class definition here will be taken from the protocol definition, and then because we were or we want to use this, or want to add this to our view controller, we also need to make sure that the protocol functions are implemented within the code itself, or within this class itself. And you can see here that this function, background task executed, basically this is the function which is the protocol function. So here you just have the protocol function defined by its name, and in the application itself where it will be called, you can fill up with your code what should be executed within this protocol function. So if you might use this protocol at different point of your application or for different reasons, so you can basically use the class itself, which is let's say working through this protocol and giving some information back to the application itself. Basically, you can multiply the function of this kind of element, and you can give the details that what this protocol should do in one case and what it should do in another case. So basically, this can be, of course, pretty much different. So you might be able to use, like I was using for a I called it web helper class, where I was basically setting up a simple standard web call or web server call to get some information from my backend server. And when I send out what I'm requesting from the server, I can get back different results from the web server. And depending on where I was calling it and what I wanted to get back, I need to handle this received information on a different way. So in this case, we only have one function, and of course we were using it only for one simple test, let's say. And what in this test the protocol function is doing, that it's displaying in the finished text field that the emulation is finished, and then it's also deleting from the start text field the emulation started text. And then, of course, what I also need to mention that once you finish the execution of such a background task and you don't want to use it anymore, then you should be canceling or deleting the task delegate variable to nil, to tell to the background task or this asynchronous task that you don't want to do anything else from this run anymore. Of course, if you might have several calls, then of course this might be an issue. So you need to be careful that how many times you are calling your functions or your asynchronous tasks, and also you need to make sure that when you get back a result, then you are handling it on the right way. There are different solutions for this. In our case, in this application, you can just see that if I would get the request, so here you can see that with the start emulation, I'm calling the simulate background task execution function within this background task emulator code. It's starting a timer, and that when the timer is finished, then this background task executed function is called, and then we will come back here. Okay, so I think this is clear. So again, how this works, just to show it again. Okay, so it's here, start emulation, background task started, and then after 5 seconds it comes to here, so the background task executed. We can start it again, of course. But every time we start, we are coming back here into this one, and we are adding again the task delegate. If you would forget to add this self, so let's take it out just to show what it happens, so why it's important. Because then when we run the application, and if we don't define that this task delegate is called, then you will see that after the 5-second finish, basically nothing will happen actually here, because this background task started text will not disappear, because it's never calling this background task executed. However, if we go back to here and we just come to this line, you will see that again, let's run it, that theoretically this line is called. So let's wait 5 seconds. So the line itself is called, but the task delegate is nil. So this function cannot call, or this delegate is nil, so it's not pointing to anywhere, and that's why the function itself is not called. So nothing happens. So you always need to make sure that if you define or you want to use a protocol, you need to have a delegate, and this delegate should have a return point or a pointer which is showing that where it should go back. So again, once we set it back again to the view controller, then with the start emulation again we can get it running. Okay, it comes here, but now it is doing the job, so it's coming back to the application. Okay, so that's the iOS version, and let's see it on the Android version. Okay, wait a moment, it's here. Okay, so I'm not going through everything here because it's pretty much the same, so I'm just going to the first fragment, where we are calling the start emulation. So here we have the button defined, and then we were having again so basically we are running this 3 lines here when we click on the button. So we were binding the emulation finished text to from the layout to the application itself, the application code, and then with the set text we are cleaning out the finished text box, and then with the emulation start task we are also defining this task delegate, and here in the Android we need to say that this is this fragment, let's say, so where we are calling the asynchronous task, and then again the emulation start text simulate background task execution. Basically this is the same thing like what we had in the iOS application, and we also defined here the background or the protocol function, or in this case it's called interface function. So in this interface function we are doing the same. So again, setting the text of the finished text box, cleaning out the text from the start text box, and then we are zeroing out or cleaning out the task delegate pointer, let's say, to 0 to finish the thing, and this function will not be called anymore. So let's and one more thing. So here when we are defining the class or the fragment, we also need to make sure that we are putting this background task emulator delegate itself into the class definition, and then we implement, of course, this protocol function in the application. So this is, I would say, exactly the same as it is in the iOS. The only difference, of course, that in the Android or in Kotlin, the button function you put into a or you use it in a different way, so you have it inside on view created, or you put it somewhere else in the application, but you need to make sure that this one is defined when the view itself is created or shown to the user. So let's see the background task itself. So this is a similar kind of class definition what we had in the iOS. Basically, we were subclassing the edit text, which we used on the layout as the first text. But now we have here a difference compared to the iOS solution or the Swift solution, that while we had the protocol function outside of the class definition, in the Kotlin version, these interfaces or protocol like function definitions are within the class. So these are directly linked to the class. But then the definition is pretty much the same, so you are just defining the name of this function, what you will use in the main, or where you will use the protocol call itself inside your code. The rest is again pretty much the same like in the iOS. So we have a simulate background task execution function. We write a text into the text field. Then we define a timer. This is of course a little bit different again from the iOS solution. But then we define the timer task, and the timer task will be this task delegate. So here we also define the task delegate here at the class definition as a variable, and we are calling basically, or we are the variable itself will be this delegate function or delegate interface variable. So here we have the same. So if we don't have this task delegate defined, or we don't have a pointer for that, it's nil or null, then this function will not call anything here. And then of course the timer will run for 5 seconds, just as in the iOS version. So if we are running this, then of course the behavior of this application is exactly the same as in the iOS version. Okay, I think. Okay, let's see. So it's here. So we start the emulation similar way as it is in the iOS, and then of course it's running the same way. So basically the solution is pretty much the same, a little bit different position or different location of the interface definition, but as you can see, the basic idea or basic solution is exactly the same in both platforms. So that's all for today. I hope you enjoyed this tutorial, and don't forget to subscribe.